Okay, coming back to proofs, except this time with parallel lines. Well, I've been kind of hinting at some of this already. So we're going to review some of the properties. Symmetric, remember, symmetry is when the left side matches the right side. Okay, so if 1 equals 2, then the measure of angle 2 equals the measure of angle 1. Okay, we can just switch left and right side. Left side equals the right side equals the left side. Addition property. Okay, do this all the time when we're solving equations. If EF equals GH and we add HJ to EF, then we're adding HJ to GF. Sorry, GH, my bad. GH plus HJ, if I can write. Multiplication, same concept. We have EF equals GH. If we do 4 times EF, then we have to do 4 times GH. Whatever we do to one side, we do to the other. Okay. It says write the converse of each statement. So remember, the converse, right, is when you just switch them. So we learned if 2 parallel lines are cut by a transversal, then the pairs of corresponding angles are congruent. Well, the converse is if, remember, converse means switch the if and the then. So if corresponding, like you can abbreviate, angles are congruent, then the lines are parallel. All we did was switch them. So the corresponding angles converse says that. Okay? If the angles are congruent, then we know the lines are parallel. All right, find the value of x that makes them parallel. Well, we know that 3x plus 5, let's just call this angle 1, and this, angle 2, are both corresponding angles because one is on the inside, one's on the outside, and they're both on the right side of the transversal. So if they are congruent, that proves the line's parallel. So we do 3x plus 5 equal to 65. So whatever number we put in there to make them equal will work. So I'm going to subtract 5 from both sides and get 60. Divide by 3, x is 20. So if I plug in 20 right here, I get 3 times 20 is 60 plus 5 is 65. So 20 makes them congruent. Therefore, the lines are parallel. All right, more rules, okay? Alternate interior. We know that if the lines are parallel, alternate interior are equal. So the converse is, if the alternate interiors are equal, then the lines are parallel. Same thing with alternate exterior. We learned previously that if the lines are parallel, alternate exterior equal, congruent. Therefore, if we know they're congruent, the lines are parallel. And earlier we learned consecutive or supplementary when the lines are parallel. So if they're supplementary, the lines are parallel. So let's do this. Now we're doing an actual proof here. So remember, we did proofs earlier with just basic algebra. We're going to do the same thing. We're always going to be answering why. So in the diagram, R and S are parallel. And number 1 is congruent to 3. Okay, we're trying to prove these two are parallel. All right, so we're going to do what we have before. Okay, we didn't do this before, but we're going to call this statements. And here's our reasons. So what were we given? R is parallel to S, and angle 1 is congruent to angle 3. Those are both given to us. Okay? Now, We know R and S are parallel. Therefore, we know 1 and 2 are congruent. So angle 1 is congruent to angle 2. How do we know that? And we can abbreviate. If lines are parallel, if we have parallel lines, then corresponding angles are congruent. Very abbreviated, but that's enough. If we have parallel lines, then corresponding angles are congruent. Okay? Now, if we know 1 equals 3 and 1 equals 2, then we know angle 3 is congruent to angle 2. And that's the transitive property. Okay? So remember, that's like if I give my friend a cold and they give another friend a cold, I basically gave that third friend a cold. Or if I like this person, I'm friends with this person, and they're friends with a third person, me and the third person will probably be friends based on similar characteristics. So if 3 is equal to 1 and 1 is equal to 2, then we know 3 is equal to 2. Okay? And therefore, we now know that P is parallel to Q, okay, because we've proven these are the same. So, and they're alternate interior. So if alternate interior angles are congruent, then we know we have parallel lines. It's really that simple. Just walk it through step by step. So the transitive property of parallel lines. If two lines are parallel to the same line, they're parallel to each other. So P is perpendicular to Q, and Q is perpendicular to R, then we know P is perpendicular to R, because they have the middle one in common, so to speak. All right, in diagram below, P is parallel to Q, and Q is parallel to R. So right off the bat, we have our given statements. So P is parallel to Q, and Q is parallel to R. So those are both given. That is supposed to be a G. All right? It just says explain your reasoning, but I'm going to put it in a proof just because it's good to practice this. So if we know P is parallel to Q and Q is parallel to R, we know that P is parallel to R. And that's a transitive property. So basically what we're doing is we're getting rid of this line, okay, and saying that's not there. And now what do we have? Now, if this is a straight line and we have 115, that means this is 65 degrees. Okay? So we don't have a number there, so let's call this angle 1. Let's just say it was. Angle 1 is 65 degrees. And we could say something like definition of a linear pair. And now that we got rid of Q, angle 8 is 65 degrees. All right. Y, alternate exterior angles of parallel lines are congruent. And there's your exit ticket on your own.